Welcome to this brand new solution video of 9709 paper 13 May-June 2023. If you like this video, please share with your friends, give it a thumbs up and subscribe to my channel so that I make many more solution video for you. Question number 1. In the given diagram, the shape ABC, this ABC has been transformed into A dash B dash C dash. This is the new diagram with two transformations sequentially. State fully the two transformations. Okay, so we know that transformations take place in this sequence. First, stretch or compression that takes place, and then translation. Okay, there is no reflection in this, so we will not consider it. So let's talk about stretch first. Let's talk about the y direction first, the vertical direction. So if this y coordinate here originally was 3 and then it became 1, that means there is a stretch vertically of 1/3, right? Because 3 became 1. So 5 became 3, which is not 5 times 1/3 is not 3. That means my assumption earlier that there is a vertical stretch is wrong. So there is no vertical stretch. Let's say if there is any horizontal stretch in x direction. So the x coordinate of A originally was 1, A dash is 2, it is doubled. Can you see? B, the x coordinate is 2, B prime or B dash, the x coordinate is 4, doubled again. C, x coordinate is 4 and C prime has 8, doubled again. So in all three cases is doubled. So we can confirm that there is a horizontal stretch by a factor of 2. Okay, which can be written as, if this was fx and this is gx, so we can write that gx is f half of x. When we say stretch by a factor of 2, in the function we write reciprocal of that. Okay, so this is the first one. First transformation is this. Second, we'll go to the translations. Let's say vertical translation. The vertical translation, the y coordinate was 3, it became 1, so down 2, right? Here 5 was the original y coordinate, it became 3, down 2 again. And C is at 4 and now it became 2, which is down 2 again. So confirmed, there is a vertical translation by 2 units down. So these are the two transformation. Let me rule out that there is no horizontal translation. X coordinate here is 1, here it is 2, so it is translated by 1 unit to the right. Okay, B, x coordinate is 2 and it became 4, which is translation by 2 again. And we have already taken care of the stretch, so horizontal translation is of no use. So these are the two transformations that took place in these two diagrams. Let's go to question number 2. Okay, question number 2 says, in the function x squared minus 6x plus c, x, where x is an element of real numbers, c is a constant, and fx is greater than 2 for all values of x, find the set of values of c. So possible set, okay. So you can say for all values of x, that means they have given us the range. They have given us the range y is greater than 2. What they mean is that if this is our graph, this is the x-axis, this is y-axis, and we have 2 here, our graph is always above this, and it's a parabola because it's a quadratic. It is above 2. It is not equal to 2, it is above 2, right? So that means the y coordinate, let's assume that this is y coordinate is 2 and x coordinate is not a, let's make it p. P2 is a point just below the vertex because it is not equal, so that's why I'm not saying it is equal to 2. Okay, so the x coordinate of vertex is always minus b over 2a from the equation, where b is minus 6, so I will write here minus 6 over 2a. A is the coefficient of x square, which is 1, so it becomes 6 over 2, which is 3. Okay, if y coordinate is p, it is 3. So what about the y coordinate? Y coordinate will be, if I substitute this 3 into the equation, will be the y coordinate. So f3 will be the y coordinate, which is 3 square minus 6 times 3 plus c. Okay, and that comes out to be 9 minus 18 plus c, which is c minus 9. Now they said that every time for all values of x, this fx c minus 9 will be greater than 2. So c minus 9 is more than 2. Then only this condition will be met, and which gives us c is greater than 11. Not 11, but greater than 11. That is the set of values of c. Well, question number 3 is about binomial expansion. We have to expand this increasing or decreasing order. They have not specified, so we will start with the expansion, simple expansion, which will be 5c0. Some people also write this as 50 is the same thing. In your formula sheet it's written like this, 50. Okay, I'm writing it 5c0. Then the first element of the bracket should be given the same exponent as this number I have started with, 0. So out of 5, 0 are with x, so remaining will be with the second element of the bracket, 5, right? So 5 plus 0 has to be 5, and these two numbers should match. Next term will be 5c1, it will increase by 1, so this will also increase by 1, but the exponent of 2 over x will go down by 1. So their sum has to be 5 all the time, and this is how I'll continue this. And now simply we will expand them one by one. 5c0 is 1, x to the power 0 is also 1, and 2 to the power 5 is 32 over x to the power 5. I expanded this bracket as well. 5c1 is 5, then x is x, and then we have 16, 2 to the power 4 is 16 over x to the power 4. Then we have 5c2, 10, x is square, and 2 cube is 8 over x cube. Then 5c3 is also 10, x cube over 4 over x square. 5c4 is just 5, x to the power 4, 2 over x. 5c5 is also 1, x to the power 5 is x to the power 5, and anything power 0 is 1. Now the final answer will be 1 times 32, and we can separate 1 over x to the power 5 from this, because we want, in second part they're saying coefficients of these numbers, so I'll separate them so that it is easier to visualize. 5 times 16 is 80, and this x will cancel with one of the x's, this will be just 3, so 80 1 over x cube. plus 10 times 8 is again 80. These two x's will cancel with two of them, so we'll be left with just one x. Then 10 times 4 is 40. This x square and this 3 will cancel, two of them will cancel, so we'll be left with just 1x. Plus 2 times 5 is 10. This x will cancel and make it 3. 10x cube. And we have x to the power 5 here. And finally this is our expansion. Okay. Part B. Part B says, in the expansion of this new thing, this one, the coefficient of x is 0. There is no number in front of x. So what will I do? I will write this in a bracket to make it easy, and I will write this a plus bx square in front of this, a plus bx square here. So a plus bx square, and the expansion of this is this, so I have written them one after another to make it easy for myself. Okay. So coefficient of x, is 0. So what will be the coefficient if I multiply a with one of them? Which one will give me x? This will give me x, right? So I will interpret this as a multiplied by 40x. That will give me x, right? Now bx square plus bx square. What will bx square multiply with here so that I get just x? So it will be this one. Why? Because 80 over 1 over x, right? See, one of this x will cancel with this, so I'm left with just x. 1x here, 1x here, and it is equal to 0x. No coefficient, that means this whole thing is equal to 0. So let's see if it gives us something. 40a x plus 80bx equal to 0x, and let's cancel x's from all of them so that we are not bothered about it, and also multiply this by 40 and 40. So what will be left? A plus 2b is equal to 0, or a is equal to minus 2b. This is the interpretation of the first one. And the coefficient of 1 over x is 80. Let's go back. A multiplied by what will be 1 over x? 1 over x. So let's do it here. Coefficient. So a multiplied by 80 over x. 80 1 over x plus bx square, which is the second term. What does it multiply with one of them so that it gives 1 over x? This one. Yeah, because we have bx square here, and if I write 81 over x cube, this x square will cancel with two of the x's here, and we'll be left with 1 over x. That's what we want. And the coefficient of it is 1, is just 80. So 80 1 over x. Coefficient of 1 over x is 80 when the combination of these two is taken into account. So what is left here? Or let's cancel 1 over x, just like we cancelled x. 1 over x cancelled, 1 over x cancelled, 1 over x cancelled. So 80a plus 80b equal to 80, and divide all of them by 80, so that it is simplified to a plus b equal to 1. Okay, and now we have two equations with us here, a equal to minus 2b and a plus b equal to 1. Let's substitute this into this. So minus 2b plus b equal to 1. That's what this will become now, which is minus b equal to 1, or b is equal to negative 1. We got the value of b. And for a we can use this one. A is minus 2 times b, and b is minus 1. a is 2. So we got both a and b constant that they were asking. Question 4. Show that this equation with tan square and sine square may be changed to cos and cos. That means both of them must be converted to cos. So let me write the original equation first. 3 tan square x minus 3 sine square x minus 4 equal to 0. So if I want to convert tan into cos, it will be like this. 3 sine square x over cos square x minus, now sine is to be converted to cos, which is equal to 1 minus cos square x minus 4 equal to 0. How come this? We know this sine square x plus cos square x equal to 1. This is a very famous identity. So if I take this cos to the right side, sine square x remains here. It becomes 1 minus cos square x. That's why. Okay, I'll convert this sine square also now. So 3 1 minus cos square x over cos square x minus 3 plus 3 cos square x, negative and negative become positive, minus 4 is minus 4 still, equal to 0. Now if I open this bracket, 3 times 1 will be 3 over cos square x. I'm separating the numerators. 3 multiplied by cos square will be minus 3 cos square x, and the denominator will remain denominator. So I separated the two terms after multiplying by 3. I will do minus 3 and minus 4 is minus 7 plus 3 cos square x equal to 0. And this cos square and cos square cancel. And we have a denominator cos square here, so which we can get rid of by how? Multiplying by cos square x. Let's multiply the whole equation by cos square x. So cos square x multiplied by 3 over cos square x. So this cos square x and cos square x cancel out. So just 3 is left here. Minus 3 times cos square x minus 7 times cos square x, and then 3 cos square x is already here, more cos square x, so it will become cos to the power 4 x equal to 0. Look at our target. We want cos square 4 first, so we'll write this one first. 3 cos to the power 4 x. Then we want cos square. So we have two cos squares, minus 3 and minus 7, minus 10 cos square x. And then c is just the constant 3 equal to 0. And they are to be found out, they said. So we can easily say now a is 3, b is negative 10, and c is 3. This is our answer. Okay. Moving on to the B part. Hence solve the equation, the same equation. Yes, it's the same equation. Just solve it between 0 and 180. So since they said hence, that means we will use the equation we got in A part, this changed equation. So this is the actual equation, but we will use this one and solve it. For solving it, let assume that cos square x is t. Yeah, why? Because this is power 4, this is power 2, this is half of it, and there is a constant. That means we can convert it to quadratic. So it becomes 3t square minus 10t plus 3 equal to 0. This equation can be written as this if cos square x is equal to t. And now I'll split the middle term. 3 times 3 is 9. So 3t square remains 3t square plus 3 remains plus 3 equal to 0. But the middle term, I'm splitting it into minus 9t and minus t. So minus 10 is still minus 10. Okay. But because I wanted to take something common out of these two and something common out of these two, that's why I split it. So 3t is the common between these two, and we'll be left with t minus 3 here. Minus nothing is common, so we'll take 1 common. So t minus 3 equal to 0, because minus is taken common, so this positive will become negative. If we expand it back, we'll get this thing. So t minus 3 is in both now, so t minus 3 is taken common, so we are left with 3t here and minus 1 here. And now simply we can make them equal to 0. So t minus 3 equal to 0. So t becomes 3. This one, 3t minus 1 equal to 0. 3t will be equal to 1. So t is equal to 1 over 3. But t was not our actual equation. It was cos square. We assumed that cos square x is t. So cos square x is equal to 3, square root both sides. So cos x, just cos x, is equal to plus or minus square root 3. Here also cos, by the same method, cos x will be plus and minus 1 over square root of 1 over 3. Okay. Square root of 3 is 1.732. That, and cos's value can never be more than 1 or less than negative 1. That means both positive and negative answers here are not acceptable. Reject. Okay. Now we'll focus on this one. So x is equal to cos inverse 1 over square root 3 plus and minus, right? This is what the x value will be here. We know that if quadrants are drawn, cos is positive here and here. But our domain given is 0 to 180 degrees. That means we'll have to just draw this one for positive. Okay. So we'll see what is cos inverse 1 over square root 3, 54.3 degrees. And from 0, if we start and reach to this line, that is our answer, 54.3 degrees. Second one will be for negative, cos inverse negative 1 over square root 3. For negative, we'll choose the second quadrant. Cos is negative here, and we will not put this negative in our calculator. We'll just write cos inverse 1 over square root 3 to get this acute angle, which obviously is 54.3 again. And if you want, with this is 180, and this line is 54.3 before 180, so we'll write 180 minus 54.3, which is 125.7 degrees. These two are the solutions of the given equation. Question number 5. A circle with this equation intersects with a line y equal to x minus 9 at points A and B. Find the coordinates of A and B. That's the question. So let's assume that this is A and this is B. So this is the line y equal to x minus 9, and this is the circle with this equation. So whenever we want to find points of intersection of any two shapes, substitute the y of one into the other. It is difficult to substitute this y into this equation. It is easier to substitute this y into this one. So that's what we're going to do now. So we will write this equation again now. X minus 1 square plus this y will be replaced by x minus 9. And then we have plus 4 square equal to 40. So it becomes x minus 1 square x minus 5 square equal to 40. And now we can find the values of x by first expanding this and then solving it. So x minus 1 square, we know a minus b whole square is a square plus b square plus 2a, sorry, minus 2ab in this case because it's negative, right? So minus 2ab. And if it is positive, we will write plus, but both of them are negative, so we'll use this one. So a square, in this case x, plus b square minus 2 times 1 times x. I will expand this also, plus x square plus 5 square minus 2 times 5 times x equal to 40. Please, in the identity itself, we have negative here and there is no negative here, so we will not write the negative 1 when we square it. It will be positive 1 only. Okay, so x square plus 1 minus 2x plus x square plus 25 minus 10x equal to, rather let's bring this 40 also to the left side and keep 0 on the right side, so it becomes negative 40 when it comes to the left side. X square and x square is 2x square minus 2x minus 10x will be minus 12x. 1 plus 25 is 26 minus 40 will be minus 14 equal to 0. Let's divide all of them by 2 because all of them are even, so it will make the equations easier to solve. 6x minus 7 equal to 0. Just like the previous question, I will break up the middle term. So 7 times 1 is 7, so it can become minus 7x plus x. So in these two, x is common, x minus 7. Nothing is common, so we write 1, x minus 7. Both of them have x minus 7 now, so x minus 7 and x here and plus 1 here. Since two multiplications are equal to 0, either of them will be equal to 0. So x minus 7 is 0. That gives us x equal to 7x plus 1 is equal to 0. That gives us x equal to negative 1. If you look at the question, it said find their coordinates. That means x coordinate is not enough. We will have to find the y coordinate also. So let's say x equal to 7. What is the y coordinate? So I can substitute this x equal to 7 either into this equation or this equation. Which one seems to be easier? This one, right? Because both the points lie on the line as well as circle. So we can substitute anywhere. So I will use this one. So y equal to, what was the first one? 7. 7 minus 9, which is minus 2. So the first point is, which one is bigger? This one. This one will be 7 minus 2. 7 is x coordinate, minus 2. Second, this was when x was equal to 7. Now x is equal to negative 1. So y is negative 1 minus 9, which is negative 10. And that makes sense. Minus 1 is smaller one, it is lower. And the line is going up, so its gradient is 1. Yeah. So these are the coordinates of points A and B. Okay, what next? Write the equation of the circle whose diameter is AB. Okay, that means we need a new circle whose diameter is AB. So that circle will be somewhat like this. So this is the diameter and the circle will be something like this. Okay. Not a good one, but yeah, this is what it will look like. So we'll find first the center of that circle, and that will be the midpoint of these 2 points. So let's call that center as C. So coordinates of C will be the midpoint minus 1 plus 7. This is how we find midpoint. Minus 1 plus 7 divided by 2 and minus 10 plus minus 2, which is minus 2 again, divided by 2, which will be 6 divided by 2, 3, and minus 6, 12 over 2, minus 6. These are the coordinates of C. And whenever we need to write the equation of a circle whose center is known to us, the equation will be like this: x minus the x coordinate square plus y minus y coordinate square equal to radius square. Yeah. So radius is the one we need to find now. So we can find radius by using this again. So let me make some space here. So what is the radius? Radius is between C and B. This is the radius, correct? So CB. This is what we're finding. We'll use the distance formula. So x2 minus x1, 7 minus 3. x2 minus x1, 7 minus 3. Plus y2 minus 2 plus minus 2 minus minus 6 square. Okay, 7 minus 3 is 4, so 16 plus minus 2 plus 6 is 4 again, so 16. 16 plus 16 square root 32. Now our equation is ready. Write the equation of a circle. Equation of a circle will be x minus 3 square plus y plus 6 square equal to radius we got square root 32 square. Square and square root cancel to complete 32. So you can write in place of this just 32, and that is the equation. In question 6, the diagram shows a sector. This is angle theta at the theta radians at the center, and r is the radius of the sector. Area is 76.8. The arc AB, this arc is 9.6 centimeters, and you have to find the area of the shaded region and then B part perimeter of the shaded region. Okay, so to find the area of the shaded region, we know the area of the shaded region will be area of the whole sector. Yes, this whole sector. If I subtract this triangle, this white triangle from the sector, I'll be left with this small shaded part. So I have to subtract the area of the triangle. But the problem is that we don't know the area of sector as well as area of triangle. And for that, we need to find this r and theta first. So let's use this fact first. So arc AB, arc length is always equal to r multiplied by the theta it is subtending at the center. And arc length they have given as 9.6 equal to r is unknown and theta. So I want to find r first, so I can isolate theta. So I can write theta is 9.6 over r. Okay. Let's use the second fact. Area of the sector is 76.8. Area of a sector is half theta r square. This is the area of a sector, and it is given as 76.8 centimeters square. So I will substitute theta by what I've got now, 9.6 over r, and then multiplied by r square equal to 76.8. I'll cancel one r with another r, and this 2 with 9.6. It becomes 4.8, and it becomes r equal to 76.8 divided by 4.8, and which comes out to be 16 centimeters. So we got our radius 16 centimeters on both sides. Now we have to find theta. and we know this is the formula for theta. 9.6 divided by 16 is theta, which will be 24, 0.6. Theta is 0.6. Okay, now we can use the here the method we had discussed. Area of the shaded part, which we have to find, equal to area of the sector. Area of the sector is given 76.8 minus area of the triangle. Area of the triangle is half AB sine C, where C is the angle between sides A and B. So I'll take this as sine OA as A, OB as B, and the theta is the angle between them. So that I will substitute here. So half A is 16, B is also 16, and the angle between them is 0.6. And now we'll get our answer. 76.8 minus, let's do this, which comes out to be 72.27. And let me write 3 to round it off. And that comes out to be how much? 4.5 centimeter square. Got the area of the shaded region. Now we need to find the perimeter in B part. Perimeter, right? For perimeter, we already know the arc AB is 9.6. Okay, so let me write 9.6 here. Now I need to find just this line AB of the triangle, and I can find the perimeter. So B part, in this triangle, let me redraw that triangle here. 16, 16, angle is 0.6, and I have to find this side, right? And the best way is to use cosine rule. Cosine rule says A square equal to B square plus C square minus 2BC cos A. This angle and this side are the opposite ones. So I will take, though it is O here, can you see? But for simplicity's sake, I will assume that this is A and this side is A. The opposite side to the angle A is A, and that's what I'm going to use now. So A is unknown side, B is 16, the other side 16 minus 2 times 16 times 16 times cos 0.6, and to find the actual length we will square root both sides. So let me put the whole thing in my calculator straight away, which comes out to be 9.4566 centimeters, which I will round it off to 9.46. So we already had 9.6, and this straight line came out to be 9.46. I will write perimeter equal to 9.6 plus 9.46. That makes a sense, right? Because they are very close to each other. 18, and this will be 1.06, so 19.06 centimeter, and again we have to round it off, so 19.1 centimeter. I hope I've not rounded off too many times. This is the answer. Question number 7 talks about a function fx equal to 2 minus 5 over x plus 2, and this is the domain given. State the range. If domain is this, what is the range? To find the domain and range of any function, if we can draw its sketch graph, it is of a great use. So what I'll do, I'll draw the parent function of this function first. What is the parent function? It's a reciprocal function. Parent function is y equal to 1 over x, right? Now we'll see what are the transformations on this. First we'll look at stretch or compression. We can see that it has been multiplied by 5. So it has become 5 over x because of this stretch in vertical direction. So the graph of y equal to 1 over x looks like this. Okay, but because of this 5, there is no change in domain or range, just the shape of the graph changes. So you can see it is away from the axis right now. It becomes a little closer. That's it, because vertically in y direction it gets stretched up, so it comes closer to the axis. This is the only change because of 5. So 5 have no role in changing domain or range. All right, now because of this plus 2, it's with x, so it will be an effect on x, horizontal direction, and it will be to the left by 2 units. So right now the asymptote is the vertical line. This line, let me erase the original one, this one. Now the asymptote will be on the left, 2 units left of 0, which is minus 2. So our new asymptote is going to be here. So this is minus 2. Okay, and the new graph will be this and this. Just the whole graph got translated to the left by 2 units. Now what? This is a negative here. That means this particular graph will be reflected. Yeah, because of this minus. So this minus, let me undo this. Reflection should have taken place earlier, but it's okay, because translation does not change it. So this is the reflected part because of this minus. And now this 2 is additional translation in vertical direction, y direction. That means this plus 2 will make this particular graph go up, and the new graph will be, let me again undo this, because of this 2, this graph will go 2 units up. So our horizontal asymptote, which was this axis first, now it will become positive 2 here, and our graph shape will remain same. So it is something like this and this. Now we can write the range for x greater than minus 2. This is minus 2. The graph which is greater than minus 2 is in this area, and which is nothing but this graph. According to this graph, what is the range? The whole graph is below 2. So we can say that range is fx is less than 2, or y is less than 2, whatever you want to write. This is the range of this graph. So it's better always to draw a graph that helps you to get the range, because the worth of this mark, this particular question, is just 1 mark. For 1 mark you can just look at the graphs. B. Obtain an expression for f inverse x and states its domain. Okay, domain is clear. Whatever is the range of the original equation, that becomes the domain of the inverse. So if it is y is less than 2, x is less than 2, this is what your domain will be, but we'll confirm it. Okay, first let's find an expression. So this was the expression. Let me rewrite it. Fx equal to 2 minus 5 over x plus 2. This was our original expression. Now we will start the inverse process. In inverse process, the fx becomes the x and x becomes fx, which is y. So that's what I'm going to write here, 2 minus 5 over y plus 2. And now my endeavor should be to isolate y, which will be the inverse. So what will I do? I'll first take this 2 with x. So x minus 2 equal to negative 5 over y plus 2. Right? Now y plus 2 and x minus 2, they can exchange their places by cross multiplication process. So Let me continue here. Y plus 2 equal to negative 5 over x minus 2. Alright, then y, this plus 2 I'll bring to the other side, equal to negative 5 over x minus 2 minus 2. This plus 2 goes there, becomes minus 2. This minus looks odd. Let me change it. Whenever we want to change such a thing, it becomes positive. I have to change the sign of the denominators also. They will become 2 minus x. Why? Minus 2 becomes positive, x becomes negative to compensate what I've done there. Okay? And this is our inverse. F inverse x is 5 over 2 minus x minus 2. And domain we had already decided to be x is less than 2, and that makes sense, yeah, because 2 will be the asymptote here. 2 minus 2 0. This will be the asymptote of this particular reciprocal function, and they had given y is greater than minus 2. Of course it is going to be greater than minus 2 because we are adding something to it. This is positive, right? So this is matching, the domain is matching, sorry, the range of this one is matching with domain of this, and this range will be the domain here. So that's it. Let's go to the next. If gx equal to x plus 3 for x is greater than 0, x is positive only, okay, write down an expression for f gx. That means gx will be inside f. That's what it means. So we can write f in bracket gx inside it. Okay, so what was fx? It was, let me write here, fx was 2 minus 5 over x plus 2. 2 minus 5 over x plus 2. So in place of x, now we have gx. That means wherever we have x, replace it with gx, which is x plus 3. And that's what I'm going to do here. 2 minus 5 over x plus 3, and then we have 2 as well. So it becomes 2 minus 5 over x plus 5. Okay, but they want this format, ax plus b over cx plus d. That means they need to be combined together. So for that they need to have same denominator, and it does not have x plus 5, so we'll forcibly write x plus 5 here, and to compensate this we will multiply this 2 with x plus 5 on top also. Alright, so 2 multiplied by x plus 5 will be 2x plus 10 over x plus 5 minus 5 over x plus 5. Okay, now 2x plus 10 minus 5 over x plus 5. I combined the two because their denominators are same now. So it becomes 2x, 10 minus 5 is 5 over x plus 5. This is the format. So we got a equal to 2, b equal to 5, c equal to 1, and d is also 5. It's turn of question number 8. A progression has first term a and the second term this. So they have not specified whether it is AP or GP. A is a positive constant, okay, for the case where progression is GP. So in A part they are confirming it is GP. The sum to infinity is 264. Find the value of A. So sum to infinity is A over 1 minus R. So sum to infinity we know 264, A and R we don't know. So let's eliminate one of them. So we can find R now. R is always any term in this case, second term, divided by the previous term. So the second term divided by the first term will give us r. So a2, second term is this, a square over a plus 2 divided by the first term, which is a. Okay, so I can write this as a square over a plus 2 multiplied by 1 over a, or a square over a plus 2. This is r. And now let's use this formula to get a, because we are eliminating r. And are they asking r? They're not asking r. Maybe in part B they might be asking, but not here. Okay, S infinity, sum to infinity is 264 equal to a divided by 1 minus r. R is a square a plus 2. Okay, it becomes a little complicated, but no problem. Don't lose your control over the situation. 264 remains 264. We need to simplify this one. So a remains a on the numerator. Here 1 does not have any denominator, so they can't be combined. So what will I do? I will write this 1 as this a plus 2 divided by a plus 2. Isn't it 1 again? So 1 written like this so that I can combine the two parts. And the second one remains a square a plus 2. Now 264 equal to, whenever things become complicated, you just lose, especially in exam scenario. I don't know whether I'm doing it right or not, but please, if you're using the right rules, it will always be okay. So a times a is a square, 2 times a is 2a, and then we have minus a square from this one. Because they have same denominator, I can combine them. I'm not writing the denominator anymore, because the denominator of a denominator is numerator. So I can write this a plus 2 on top to make it simpler and cleaner. So a was already here. A plus 2 came from the denominator of the denominator. So 264 equal to a square a plus 2 is the numerator now, and these two cancel, a square minus a square, so we are just left with 2a, and one of the a's will cancel with this a, so it becomes even simpler. Now just 2 left here. 2 can cross multiply with this, so it will be 528. Yeah, and here it will be a square plus 2a, and this becomes our quadratic equation now. A square plus 2a minus 528, and we have to just solve this. There are many ways of doing it. You can use a quadratic formula which is given to you in the exams, but I think I can find the factors of 528. It is 264 times 2, so this is 24 times 11. I'm doing it mentally. You can use your quadratic formula, no matter. So 11 times 2 is 22 and 24. So these are the ones which will give us 2a. So let me solve it here. A square remains a square, minus 520 remains 528. The middle one will become 24. I got from here positive 24 and minus 22a. So the common between them is a. So a plus 24 minus 22a plus, plus 24 equal to 0, because there is negative and I've taken that negative common. So second one become positive. A plus 24 is common from both now. A minus 22 equal to 0, and this gives us a plus 24 equal to 0, so a is negative 24. A minus 22 equal to 0, a is 22. And this is your answer, because they've clearly said that a is a positive constant. This is a negative constant, so we reject this answer. This is not the answer. A equal to 22 is the answer. Okay, let's see what is the second part saying. For the case where it is an AP, okay, so in this case it is arithmetic progression. A is given here, very good. So let's write the values. A1 was A2 was A square divided by A plus 2. They're given A equal to 6. So we can give here, the first term is 6, and this becomes 6 square over 6 plus 2, which is 36 divided by 8 divided by 4 divided by 4. So 9 over 2, 4.5 is A2. This gives us D. Common difference will be A2 minus A1. Just like in GP, it was A2 divided by A1. In AP, it is minus. So it becomes 4.5 minus 6, negative 1.5. Okay, so we got D as well. Find the least value of n required for the sum of the first n terms less than minus 480. Okay, sum of the first n terms, Sn, is given in your formula sheet also. This is the formula. This has to be less than negative 480. So what will we do? We'll make it equal. Let's not keep it an inequality. It becomes we'll make it an equal sign, and whatever answer we get at that point, it is crossing minus 480. So we'll go to the next n. Obviously our answer will be in decimal here, I'm sure. So because we have assumed it to be equal, so we will go to the next n, because n cannot be a decimal. So we'll take care of that one on the last step. So let's make it equal, and this 2 will multiply with this 480. So we can keep here n, 2 times A, 2 times 6. N we don't know, but we know D, negative 1.5 is equal to, and this 2 is going to multiply with 480, becomes 960. So denominator is gone. Now we can multiply this. N multiplied by 12 is 12n. N multiplied, n multiplied by n is n square, but this is also multiplying with negative 1.5. So negative 1.5 n square. N multiplies with negative 1 is minus n, and multiplies with this becomes plus 1.5. And let's bring 960 to the left side to make it quadratic, equal to 0. Let me take a pause and ensure that it is correct. 12 negative 1.5 n square, positive 1.5, just the number n. Alright, so I'll take minus 1.5 n square at the leading term because it's square. 12 plus 1.5 is 13.5 n plus 960 equal to 0. Since I'm sure that this will be a decimal answer, the middle term splitting like I did in previous part, let me show you. Like I split it here in this one, I split 528 and then I got 24 and 22. That is not possible here because it is going to be a decimal number, so it's better to use our favorite quadratic formula again. So b square minus 4ac over 2a. So what is minus b? 13.5. Negative 13.5 plus minus square root. Oh, let me only do the positive first. Okay, I'll come back to the negative one later. 13.5 square minus 4 times a is negative 1.5 times 960 is c, divided by 2 times negative 1.5. So okay, because of this negative, this is not going to be a good number. So let's see, let me use my calculator for this. And I got minus 20.195 in this case, which is not acceptable because number of terms cannot be negative. That means we have to go to the negative one now from here. So negative 13.5 minus 13.5 square. Let me make it positive because these two negatives will make it positive. 4 times 1.56 times 960 over minus 3. Yeah, 2 times negative 1.5. And that gives me 30.195. And I told you whatever is the decimal will go to the next one. So n comes out to be 31. 31st term. If I add terms up to 31st, it will be less than minus 480. So that's the final answer in this case. Question number 9. A curve y equal to fx passes through 0, 3 point such that its first derivative is this. Find the equation of the curve. So from first derivative, if we want to find the equation of the curve, which is fx, we'll have to integrate this. Let me write it again. F prime x is equal to 1 minus 2 over okay. So if I integrate this one and integrate the right side as well with respect to x, what will that be? The integration of the first derivative is the equation of the curve, the function itself. Okay, the integration of 1 will be x minus. For this, let me do some work here. I can write this as minus 2 x minus 1 to the power negative 3. This cube goes up and becomes negative. And now I have to integrate this. So to integrate this, it will be minus 2. The exponent of this will go up by 1 and we'll divide it by the same exponent, minus 3 plus 1, whatever was there, and further we'll have to divide it by the differentiation of what was inside the bracket, and x minus 1, differentiation of x minus 1 is just 1, so we'll divide by just 1, which is not going to make any difference, but this should be a habit to do so that if there is some complicated integration you don't forget. So I'll write this here now. So it will be minus 2 x minus 1 to the power minus 2 divided by minus 2 times 1, and I'm ignoring 1 now. This minus 2 and this minus 2 will cancel and this will become positive as a result, and plus c. This will be the equation of the curve, but we have to evaluate c with the help of the point they have given. So in which the y coordinate fx is 3, so 3 is equal to x is 0 plus 0 minus 1 to the power minus 2 plus c. So 3 is 3, 0 we can ignore, and minus 1 to the power square, when this minus 2 becomes positive as a denominator, it will become positive 1. So 1 plus c, and if 1 comes here, 3 minus 1 is 2. So c comes out to be 2, and the equation becomes y equal to fx, okay, y equal to fx, and fx is this, x plus, and let me make it positive, this minus 2 positive by making it denominator again, x minus 1 square, and plus c we got 2. This is the equation of the curve. Okay, let's see what next. The tangent to the curve at 0, 3, okay, intersects the curve second time again at P. Suppose this is the curve and the tangent, this is 0, 3, okay, this is the point where we have coordinate 0, 3. Tangent will be this on this point, and it will intersect the curve again at P. And we have to find x coordinate of this P, right? So first we need to find the equation of the tangent so that we can find the point of intersection of that tangent and the curve again. First point of intersection is 0, 3 itself. We have to find the second one. Okay, so let's find the equation of this tangent. Equation of any line, tangent is a line, right, is y minus y1 equal to mx minus x1, where x1, y1 are the coordinates of the point on the line, and we know 0, 3 is a point on the tangent. Y and x will be the general points on the line, so we don't need to evaluate them. Just m is needed, gradient of the tangent. And what is gradient of the tangent? M is same as f. This is the gradient, and we'll just put the value of x. What is the value of x at this particular point? 0. So what was f prime x? 1 minus 2, this one, 1 minus 2 over x minus 1 cube. So it was 1 minus 2 over x minus 1 cube. This is 0. Yeah, because our x coordinate is 0. So we'll write it f0 here. And what does it give us? 1 minus 2 over negative 1 cube will be negative 1. So this and this cancel. So m comes out to be 1 plus 2, 3. So we know 3 now, and we can substitute the values. Y minus y1 is 3, the y coordinate. M, we just got 3, x minus, and x coordinate is 0. So what do we get here? Y equal to 3x, and this minus 3 comes to the right side, becomes plus 3. This is the equation of the tangent. But this was not the requirement. The requirement was the coordinate of P. And now we can equate this 3x plus 3 with the curve here, because the y coordinate will be same at P for the curve as well as tangent. And we'll make a new equation out of it, which is, let me do it here, 3x plus 3, which is the y coordinate of the line, and x plus 1 over x minus 1 square plus 2, which is the y coordinate of the curve. They are equated, and just we have to just rearrange them. So I brought this x and this 2 to the left side. They became both negative, equal to only 1 over x minus 1 left here. So 3x minus x is 2x. Let me finish it here. 2x, and 3 minus 2 is 1, equal to 1 over, and now we can cross multiply. This x minus 1 will square will multiply with this, and we are close to what they wanted us to show, equal to 1. And if I bring this 1 to the left side, we get exactly what they want. Minus 1 equal to 0. And 2x plus 1, x minus 1 square minus 1 equal to 0. We showed what they wanted us to do. Okay. Now, verify that x equal to 3. Okay, that means I have to use this. Verify that x equal to 3 over 2 satisfies this equation, this one, and hence find the y coordinate. So we'll just substitute x equal to 3 over 2 here in this one. So 2 times 3 over 2 plus 1, 3 over 2 minus 1 square minus 1 equal to, okay, rather we'll just do LHS, left hand side, it has to be equal to 0. Okay, 2 and 2 cancel, 3 plus 1, 4, Then 3 over 2 minus 1 will be half. Minus 1. So 4 times 1 over 4 minus 1. 4 and 4 cancel. 1 minus 1 is equal to 0, which is right hand side. We verified. So hence we have to find the y coordinates of P. Okay, let's go back to the drawing again. So this is P. It lies on the line as well as the curve. So it will be better to substitute that x coordinate here in this, and we'll get the y coordinate of P, 3x plus 3. That's what we're going to do now. So it was y equal to 3x plus 3. So x equal to 3 over 2, that's what they're saying. So y is 3 times 3 over 2 plus 3, 9 over 2, which is 15 over 2. This is the y coordinate of P. The final question, number 10. The diagram shows points A and B on this curve. Find the coordinates of the maximum point of the curve. So this is the maximum point. We need to find its coordinates. So we have been given the coordinates of A and B. So to find the maximum point, so we can write for maximum point, the gradient of the tangent at that point is equal to 0, and gradient of the tangent, let me show you, this is the tangent, and we can see its gradient is 0. It's a horizontal line, so it is basically f prime x or y prime, the first derivative will be equal to 0. That means we have to find the first derivative of y equal to 9x, this one. Okay, so y prime will be, the differentiation of 9x is just 9, minus differentiation of this will be the exponent 3 over 2 will come in front, then 2x plus 1 remains 2x plus 1, and the exponent goes down by 1. Further we'll have to multiply by the differentiation of what was inside the bracket. So differentiation of 2x plus 1 will be just 2, because the differentiation of 1 is 0, so just 2. This 2 and this 2 can cancel, so y prime is 9 minus 3 2x plus 1 to the power half. This is the first derivative, and we have to make it equal to 0. So this becomes our equation which we need to solve and find the x coordinate. So 9 will stay on the left side, and this is negative, which will go to the other side and become positive. Okay, we can divide both sides by 3 to get rid of this 3. So 3 is equal to power half can be written as square root 2x plus 1, and to get the values of x we'll have to square both sides. So 9 is equal to 2x plus 1. 1 can go to the left side, so 9 minus 1 equal to 2x. 8 equal to 2x, and if we divide both sides by 2, x comes out to be 4. So this is the x coordinate of the maximum point here. So 4 is the x coordinate. To find y coordinate, we'll substitute this 4 into the equation, main equation of the curve, which is this one. So y equal to 9 times 4, x is 4 for us now, minus 2 times 4 plus 1 to the power 3 over 2. It is 36 minus 8 plus 1 9 to the power 3 over 2. You can use your calculator. I will do it mentally. So square root of 9 is 3, cube is 27. So 36 minus 27, which is 9. So the coordinates of maximum point are x is 4, y is 9. Okay, what next? Verify that the line AB is the normal to the curve A. So this line AB is a normal. That's what they mean to say. So what we can see, that this is the tangent. We have to prove that this is 90 degree to the tangent, and the gradient of tangent is nothing but the first derivative which we got as this one. Let me rewrite this one. Y prime was 9 minus 3 2x plus 1 to the power half. This was the general rule for the tangent, and we know that the x coordinate here is 1.5 at A. We substitute 1.5 here and we'll get our gradient of the tangent. Then we'll show that it is what we got earlier was a normal. So this is the one, and we'll substitute the coordinates of A, which was 3 over 2. So gradient of tangent at A equal to 9 minus 3 2 times 3 over 2 plus 1 to the power half. This 2 and this 2 cancel. 3 plus 1 is 4 and square root of 4 is 2. So it becomes 9 minus 3 times 2, which is 9 minus 6 equal to 3. Now the gradient of to normal at A will be negative reciprocal of 3. Negative reciprocal of 3 is minus 1 over 3. So if the gradient of the line AB, if the gradient of this line is negative 1 over 3, that becomes a normal. So we have these 2 points here, 1.5, 5.5, 7.5, 3.5. So let me write here. The 2 points are A 1.5, 5.5, and B is 7.5 and 3.5. Let me verify once. Yes. So gradient of AB. Let's see. So we know it is y2 minus y1 over x2 minus x1 for any line, and we know all the coordinates. We'll just substitute their values. So let's say this is y2, and I will make it a improper fraction, so it will be 7 over 2 minus 5 times 2, 11 over 2 divided by x2, 15 over 2 minus 1.5, which is 3 over 2. So what does this give us? 7 minus 11 is minus 4 over 2 over 15 minus 12 over 2. So what do we get? Minus 2 over 6, and which is negative 1 over 3. Verified. The gradient of AB is same as the gradient of normal. That's why AB is the normal at A. Alright. Next, part C. Find the area of the shaded region, not shaded, shaded region. And let me copy the drawing here. Done that. So now let me plan how I will do it. I will do what? I will find the area under this curve from this point to this point. And what will I get? I will get this shaded area plus the area which is white between these 2 points. This whole area I will get if I find the area under this curve from 1.5 to 7.5. Okay, and then what will I do? I will subtract this white part, which is a trapezium, yes, from the area I get under this curve from 1.5 to 7.5. That's my plan. So let me write here, area of the shaded region will be area under curve minus area of the trapezium. Let me find the area of the trapezium first. So this is the trapezium. Let me do this one. So the height, this height will be the y coordinate of point A, 5.5, which is 11/2. The height of this line will be the y coordinate of this point B, which is 7/2. And the distance, perpendicular distance between them is this, which is the height of the trapezium. It will be 7.5, yeah, 7.5 minus 1.5, which is 6. So we know the height, we know the length of two parallel lines, we can find the area of trapezium. Let me do it here. Area of trapezium equal to half first parallel line, second parallel line times height, right? So half first parallel line is 11/2, second parallel line is 7/2, and the height between them is 6. 2 and 6 may get cancelled out, so 11 plus 7, 18/2, 9 times 3, which is 27. This is the area of the trapezium. Now we have to find the area under curve. Which will be the integration of this curve from 1.5, which is 3/2, till 15/2, and we'll have to integrate the function 2x plus 1 to the power okay, so let me integrate. 9x will be 9x square over 2 minus 2x plus 1, and the exponent will go up by 1 and will divide by the same. Further, we have to divide by the differentiation of this, which is 2. Okay, yeah, plus c from 3/2 till 15/2. Okay, so it becomes shall I? Okay, yes, 9/2 x square minus 2x plus 1 to the power 5/2 over, this will be 5/2, but this 2 cancels with 2, so we'll be just left with 5. Okay, 5/2 times 2 will be just 5, nothing else, plus c. And now we will substitute 15/2 and 3/2 in this and we'll get it. So let's substitute 15/2 first. So 9/2, 15/2 square minus 2, let me write 1/5 outside, this 1/5 outside, so that I can write this is 1. 2 times 15/2 plus 1 to the power 5/2 plus c. This is 1, I substitute 15/2. Now I'll substitute 3/2 minus 9/2, 3/2 square minus 1/5, 2 times 3/2, they'll cancel out, huh? plus 1 to the power 5/2 plus c. Because of this minus, both c's will get cancelled out. This is just a ritual to write them. Okay, this will be 225 times this, 2 over 2 square is 8. Okay, I'm doing it mentally. You can use your calculator straight away. There's no doubt. There should not be any confusion about this. So this will be 1024 over 5. Okay, yeah, 16, 4, 5, 1024. Minus. This will be 9 times 9, 81 over 4, 8. And this minus will be positive. And how much will that be? 32 over 5. So this minus this will give me 4, 8 minus this will be how much? 32. So 24, 8, 992 over 5. So 243 minus 992 over 5 gives me 44.6 units square. This is the area of the whole blue colored I have drawn just now, and I have to remove trapezium from it, and trapezium's angle area was 27. So it will be area of the shaded part will be 44.6 minus 27, which is 17, yeah, 0.6 units square. That's the area of the shaded part. Thank you for watching this video. If you liked it, please show it by clicking at the thumbs up, and share this video with your friends, and don't forget to subscribe to my channel to see many more solution videos in future. Thank you so much.